Hello everyone, this is Niteen Mohod, and here we are going to see the basics of optoelectronic devices. Here opto stands for the light. Here under basics of optoelectronic devices, we are going to discuss 3-4 devices, wherein the first device which we are going to discuss will be LDR. But before that, we will see the basics of optoelectronic devices. Electronic devices which can detect the light or can generate the light or interact with light or even can control light comes under the category of optoelectronic devices. Some of the optoelectronic devices are LDR, light dependent resistor, then LED, which is light emitting diode, photodiode, phototransistor, photovoltaic cell, also called as solar cell. Here you can see the photo stands for light. Photoresistor or photoconductor are the another name of the light dependent resistor, that is LDR. Means LDR is identified as photoresistor also and photoconductor also. Its resistance decreases with increase in intensity of incident light, and hence it is used in light sensing circuits. Basically it uses high resistance semiconductors, and hence when light falls on such semiconductors, bonded electron gets free on receiving light energy from the incident photons, that is light particles, and jumps from the valence band to the conduction band, and the electron hole pairs are generated. It results in increase in charge carriers and naturally will result in increase of conductivity, and which will decrease the resistance. Generation of charge carriers due to light particles, that is photons. Symbol of LDR and the actual LDR is as shown. Here you can see clearly the electrons are moving from this valence band to the conduction band when the light falls on the semiconductor, and because of which the electron hole pairs are generated and the conductivity increases, leading to decrease of resistance. This is the symbol of LDR, while actual LDR looks like this. Characteristics of LDR are as shown. They are obtained by plotting the graph between the intensity of incident light versus the change in resistance of the LDR. They are non-linear in nature, as you can see. Indicates that the intensity of incident light is inversely proportional to the resistance of LDR. As you can see, as the intensity of light increases, the resistance comes down. Features of LDR are wide frequency response they are having. It has low cost and wide ambient temperature range, that is surrounding temperature range. Applications of LDR are sensitive light operated relays, means mechanical switches. They can be used as a mechanical switches which will be sensitive. Then it can be used as a light detector, then security alarms, street lights, light interruption detectors, and automatic light circuits. I hope the idea about the basics of optoelectronic devices and LDR is clear to you. Please don't forget to like, share and subscribe the channel. Thank you.